When we have a large population and we want to answer questions about that population, we can use a sample. Sometimes samples are appropriate and sometimes they won't be. So if we look at these questions here, Rhian wants to find out how many times people in Wales exercise per week. A sample would be appropriate because you've got a large population, the entire population of Wales. Simon wants to find out if people in his form class have a pet or not. A sample would not be appropriate. You may as well just ask everyone in the form class. Sam wants to find out how many people in his office have bicycles. Again, I would say he could ask them individually. Unless it's an extremely large office, then a sample would not be appropriate. Sean wants to find out which brand of games consoles was popular in the country. Again, a sample would be appropriate there because of the number of people in the country. Here are some questions for us to think about. To take a systematic sample of 8 from a list of 45 people, what would be a sensible interval to use? Well, a systematic sample is one where all of the members are equally far apart. So a sensible interval would be 45 over 8, which is approximately 5. I mean, really, it's going to be 5 and 5/8, which is approximately 5 if we round down. So we could have an interval of 5. There were 400 trees in a plantation. All the trees have been planted in rows. Describe how to make a systematic sample of 25 trees. Well, what we could do is firstly work out the interval, 400 divided by 25. So that's going to be 16. And then you could choose every 16th tree. So you could choose the first tree and then the next, and then from there every 16th tree. And that would be a systematic sample of the 25 trees. Wouldn't necessarily be random unless you choose a random number to start with. Number 3, the houses in the street are numbered from 1 to 340. Describe how to create a systematic sample of size 20. Again, it's the same idea. We would simply do 340 divided by 20, which is 17, and then we could pick the first house, the 17th house, the 34th house, and so on. Random sampling is a kind of sampling where every member of the population has an equally likely chance of being chosen for the sample. A larger sample does mean that your results will be more reliable because it becomes more representative of the population. Here's an example of a GCSE question on sampling. So one morning, Simon decided to carry out a survey to find the mean handspan of people in Wales. He decided to sample systematically. So he took a sample from the first 240 people who passed him in the street during the morning. He wanted 20 people's hand measurements. Explain how we could use systematic sampling to obtain 20 measurements. So what he needs to do is 240 divided by 20, which will give us 12. Will give us 12. So what he could do is choose every 12th person who passed him in the morning. Then he would have a sample of 20. So he could choose every 12th person who passed him. And he could start from the first person. This is how we would do random sampling in practice. The hospital decides to take a random sample of its 120 doctors to select those needed for the survey. So this is obviously a question to do with a hospital. Use the following list of random numbers to select the first 5 doctors. You must start with the first number in the list and explain clearly how you were using the numbers to select the sample. So what we could do here, we want to select the first 5 doctors. So what I'm going to do is say that every doctor in the hospital, so there's 120 doctors in the sample. So, there were 120 doctors, not in the sample, 120 doctors in the population. I'm going to give every doctor a number. So every doctor is to have a unique 3-digit number from 0, 0, 0 to 120. So you can imagine all of the doctors being in a row from 0, 0, 0 all the way up to 120. And basically we're going to choose, or we're going to go working in rows. So we will go across working in rows, and we're going to choose any numbers between 0, 0, 0 and 120, and ignore any repeats and ignore anything outside of that range. So 032, that's within our range, and we haven't seen it before obviously, so we circle it and select it for the sample. 520 is too big, it's way outside of our range. 021 is fine, that's in our range. 924 no, 152 no. So we can see that none of those will be selected. 081 is great, and we're going to carry on until we've found 5 appropriate numbers. .032 is in the range, but we've already seen that number, so we're not going to do it again. 055 is good. And there's only one more that we need. And 105 is within the range, and we haven't yet seen it, so that's fine. So we're going to select doctors 032, so the 32nd doctor, the 21st, the 81st, the 55th, and the 105th. Here's a question for you to try. Please pause the video now and have a go at it, and when you're ready for the answer, press play. Just one thing to note, you need to start with the first number and work to the right. Here is the answer. These should be the numbers that we select. And these should be the 8 numbers that are selected. And again, this is how we've done it. We've given each pupil a unique 3-digit number from 001 to 450. I started at 42, worked across in rows, selecting the numbers within the range 001 to 450, and ignored any repeats.